Well, this is our first chapter in the book. First thing I want you to do is realize you will need to read the textbook. There will be material that is not covered in the lectures, and you need to read them and be familiar with them. Lecture tends to be more of the material that's difficult to others understand, and I don't cover things that you can just read in the text and grasp it pretty easily. The chapters are broken into smaller lectures so that you can watch them in 15 minutes or so, little online lectures. The first part of chapter 1 is on changes, chemical and physical changes, and measurements. The most important thing for you to know that is a difference between physical and chemical changes is that physical changes are changes in state, meaning solid to liquid or liquid to gas. It has nothing to do with the composition of the chemical. With a chemical change, it is that there are bonds that are broken and new things are formed. For instance, a physical change of water would be that it might go from liquid water to solid water. That's called crystallization. A chemical change of water is where you do something called electrolysis of water, and it changes it from water into hydrogen gas and oxygen gas. There were bonds between the hydrogen and the oxygen, and now those bonds are broken, and now there's just bonds between a hydrogen and a hydrogen, and bonds between an oxygen and an oxygen. There are no longer bonds between oxygen and hydrogen. That's the difference of a physical change and a chemical change. A physical change is just that you have a change in the physical state, whether it's a solid, liquid, or gas. And with a chemical change, there's a change in the formula. So, what happens with a physical change is that a substance remains the same thing. So the initial substance, like water, is the same thing as the final substance, water. No bonds are broken. In chemical change, the old bonds are broken and new bonds are formed. The initial substances, like water, are gone, and new substances, hydrogen gas and oxygen gas, have been formed in their place. And when we say a substance, what we mean about a substance is that it's something that is a pure element or a pure compound, that it's not a mixture of things. And so a substance can be anything that is pure. Now, what we will do initially is look at measurements. When you go to take a measurement, the number of digits that you record is determined by the precision of the instrument. The precision of the instrument is how the instrument is marked. Some instruments will have a precision like plus or minus 0.01 milliliter, but the way that we're going to be looking at this is that you will look on your instrument and you will look for the smallest increment that you have. For instance, is the increments marked in tenths, in ones, in hundredths? What you always do is record to the last place that is marked, and then you estimate one place more. Here's an example. This top line right here. You can see that the smallest increments here is 1. Not tens, not tenths, it's 1. Therefore, we record 5 because right here we can see it is close to the 5, or it's past the 5. But because the markings are for the ones place, well then we'll make a mark and estimate a tenths place. And I'm estimating that this is 0.4 right here. You might say it's 0.3 or 0.5. But I'm just saying that this is 0.4. So now I would record my measurement as 5.4. But down here on this example, you can see the smallest increment is tenths. That's a tenth. So that means that I will record 5.3 and then estimate one more digit for the space because it's between the 3 and the 4 here. And my estimate by reading this is 0.07, so I would write 5.37. Now you might say, well, I think that's 0.6 or I think that's 0.8, and that's fine. It's an estimate for that last one, and if you estimate it differently from me, that's fine. These are what are called significant digits, which are all the digits in a number that are measured and known with a certainty, plus one uncertain digit. Here are some problems for you to try. I want you to press the pause button and go ahead and do these things. Look at the centimeter ruler here. It may not be centimeter on your display, but try to measure your fingernail with a centimeter ruler. It's not what is the measurement, it's how you do your measurement that I'm interested in. And then also look at the syringe, and if this syringe were half full, right here, how would you record this? Remember to use the markings to determine how you would write down your measurement.
Okay, the first thing that you notice is that the ruler has markings for the ones place and for the tenths place. So you write a digit for the ones place, and then you notice that the finger extends to between 0.3 and 0.4, so then you write 0.3. Now, we also notice that we can, that although the markings end for the tenths place, there is an area that extends between 0.3 and 0.4. So we estimate another digit, even though there's no marking for it, we always estimate one more digit than there are markings for. And then finally, what we must write is a unit. Every number that you write, every measurement, must have a unit on it, because a number without a unit is meaningless. If I look at the syringe, you can see that the markings on the syringe, that there are markings for the tenths place, and there are markings between 0.4 and 0.5, and you can see there's little individual markings between those, and that would be for the hundredths place. So we're going to record to the tenths place and then for the hundredths place, because there's markings for the hundredths place. Then, if it's half full, we would estimate one more digit, and that would be to the thousandths place. It's an estimation, and we would look to see how close it is to the mark to figure out what digit we would write for that last thousandth place. And then, of course, we must write a unit afterwards. The unit milliliter must be there so that we know what the 0.5 stands for, because is it 0.5 kilograms, 0.5 milliliters, or what? You have to have a unit so that you know what you're talking about. One thing I want to point out with this number is that you can see that the number starts with 0 and then a decimal. Having a 0 in front of your decimal, if there's no digit in front of the decimal, it's very important to write a 0 in front of the decimal. If you write a 0 in front of your decimal, then you can differentiate between 500 with a stray mark next to it and 0.5. This is very important in the hospital. It is something that they are trying to train people in the medical area to do, because it's very easy to misunderstand directions if you write 0.5 instead of 0.5, because that decimal may not be noticed. The 0 highlights that decimal and makes it very, very clear. And one thing that we're very concerned with is making sure we communicate exactly what we mean. Now, you are going to see that we're skipping over the part of the chapter having to do with significant figures. These are significant figures are figures that we measured, and we're not going to be doing any computations considering significant figures. The book spends a lot of time examining how this is done. We're going to take that time and instead go on to other things. In the medical field does not utilize significant figures. All of the other areas of science, including medical research, do use significant figures. So if you were to go on and do science, you would need to learn about this. But because this course is emphasizing chemistry for non-research medical areas, we will not consider significant figures.
Back of your book, you will find that they are expressed in significant figures, and sometimes your answers will not match the answers at the end of the chapter because of significant figures. For instance, you might have on your calculator 24.578 grams, and that's what you write down as the correct answer. But using significant figures, the book comes up with 24.6. Realize the difference is due to significant figures, and you have not gotten it wrong. This is just a difference in expressing how you round it off due to significant figures, and don't let that bother you.